So I think just about time to start now. I'll share my screen to just bear with me a second and I will. Everybody, welcome again to another day that we are going to go through a few things again on ARA. And today we are going to focus mostly on general data distribution and data visualization. So that is the main uh, thing that we're going to focus on today. And I believe at this moment, at this point in our boot camp, everybody is familiar on how we import data frames or data sets in ARA. Or perhaps if you want to create your own data set, you can create your own data set in ARA. So what we're going to do today is just leverage the data set that we had previously. So I think in the last few weeks, I shared with you the sales data set. So we are still going to use the same sales data set, and we're going to see how we can create visuals from that sales data set. And we are going to discuss what is actually the importance of having visuals. Why should you actually visualize your data instead of having like a tabular format? Because you could still see the same data in Excel, but why do you really need to create a visual? Now, as I mentioned earlier, the session today is going to mainly focus on visualization in ARA. And if you remember earlier, I think in the first session, we defined what a visual is. So actually, a visual is a graphical representation of your data. So for your data to be more clear and more understandable, you need to convert that data into a visual. So a visual tells a good story about the data. Um, so as a data analyst or data scientist, you will deal with the raw data, but other stakeholders like people in management, your clients or anyone else wouldn't need to see the raw data, but they want to see the graphical representation of the raw data. That is something which is very easy for anyone to understand and make sense out of it. So we're going to learn how to do those visuals. And throughout our bootcamp, at different stages, we have done this. So it's not a completely new thing that we're going to do, but more rather we are going to focus on how to create these visuals in details. Now, as I mentioned earlier, ARA graphics plays a very crucial role in carrying out important features of the data. So you can examine the distribution or relationship between different variables and a summary of a very large data. So imagine if I give you a data with 1 million entries. That is a very huge data set. So for you to be able to know what's happening in the data, you need a visual to present that data. And you could present different metrics, maybe categorize categorical variables. And when I say categorical variables, I mean those variables that have nature of a string or character in R. So for example, in our sales data set, we have um, where the sales was made in terms of a region, how the sales was made, either online or in store, details of the customer, details about the customer agenda, and details about the sales amount, and details of the product that was sold, and the quantity of the product that was sold. Now, you want maybe to visualize how many sales were made in store and how many sales were made online. So there's two things here. If you say how many sales were made in store and online, so you want to know exactly the number of transactions that happened online and the number of transactions that happened on store. So that is basically counting. You're doing just the count. But it doesn't necessarily mean if you made more sales online in terms of count, it doesn't mean you generated more revenue online rather than store. Well, you can make that assumption, but it really depends on the sales value that you're making on in an online transaction. So you might have a lot of sales online, but those sales have very small margins, and you might have very less, or in terms of count, very less sales in store, but you have the total aggregate sales large because maybe people who come to purchase on store, they do bulk purchases. And it's very common because when it comes to money, if you're buying a thing maybe that worth 10 million TZS, somebody would actually really want to go to the store and verify if that thing first exists and if that's the quality that they need. So maybe it makes sense. Few people come to the store and they generate a lot of revenue from that. But online sales, maybe you have a lot of transaction online because it's easy for somebody to get something online, but fairly the value of money they would purchase maybe just say something that is not that material. So there will be a lot of volume of sales, but the total generated sales amount will be low. So that is an example that I'm giving you. And if you do this kind of analysis, you need to have a reason behind why this happens. Why are we having large volume of sales and small amount of sales? what what actually explains this. And this is the something that people want to know from you as data analysts and data scientists. Um, now, so the different ways you can present your data. You can use different visuals. You can use a scatter plot. You can use a pie chart, box plot, bar plots, etc. There's a lot. There's a lot of visuals you can use in ARA and in any other business intelligence tool. The decision is yours, which plot to use at what time, but that decision should be logical. Should be logical in terms of if you want to show distribution, the best plot you can use here is a pie chart. Pie chart can actually show you a distribution. But if you want to see relationship, and relationship is basically between two numeric variables. Maybe if you want to see the relationship between sales amount and profits, naturally you'd use a scatter plot there and you expect a positive correlation between sales and profit because profit is a part of sales. So when sales goes up, profit goes up, provided the cost is still the same. So at least if you fixed the cost, you would you'd expect a positive correlation there, unless if you're making more sales and your cost of sales is actually going high, so the profit margin is actually not changing. That's where you would maybe expect a different type of correlation. If you want to see distribution of data again, you could use box plot. Uh, they're very good in showing distribution of data. If you want to see again distribution, you can use bar plots and other kind of visuals. And in ARA, we saw that you could plot your visual and extract it in terms of an image or a PDF or an SVG file. So there's different uh, graphic devices that you can use to extract the visuals that you have created in ARA. And the most common package that is used in ARA is the ggplot. So ggplot is very popular in plotting ARA, but there's also ggvis for visualization. VIS is visualization. So it's your choice. Maybe you can plot an histogram using ggplot, or you can plot a histogram using a normal histogram function. So the decision there is yours. We are going to see both methods, and the one that works well for you, you can opt to go with it. They have a very little, slightly difference in terms of the parameters that you provide for all the two methods for creating visuals. But the most important thing that I want you to understand at this point is this. You cannot plot a scatter chart or a scatter plot with the data that is meant to show distribution. So for example, if I want to see from the data set that you have that I've shared with you, and I will share it again today, if you want to see a distribution of sales per region, you cannot use the scatter plot there because the scatter plot, actually, I cannot say that you cannot use it. You can use it, but you won't get sensible results. So you need to know you need to know what visual to use at what time. And if you create a visual in Ara, and if you feel that that visual is not descriptive or it does not add any value, it's not worth having it. So you might end up confusing people if you just uh, create visuals here and there to put in your report so that your report can look fancy, but there's no actually any story being told by those visuals, and they are very hard to read. They are very cluttered. So you need to be very smart and intelligent in terms of analyzing the visual. There's another visual here which is called a line chart that I've not included, but it's very popular when you want to see time series. So for example, in our sales data set, we have a date when the sales was made, and we have the amount tagged to that date. So you can plot a time series and see how was sales, uh, how does sales behave within time. And this is very like popular when you are looking for things like seasonality of sales. Um, Here in Europe, you have a lot of like seasons. You have summer, winter. So in summer, it's a bit hot, so you'd expect products like coats, rain boots, umbrellas to have less amount of sales and more sales maybe in more casual clothes and casual dresses. But in winter, the opposite happens. You see a lot of sales in coats, a lot of sales in winter boots, a lot of sales in heaters and heating clothes and everything else. So a line chart can actually tell you per product category, it can show you the movement or the seasonality of sales. So if you draw a line chart, you can see during during winter time, those winter clothes, you have a lot of sales, and during summer, you have less amount of sales in those. So as a sales manager or a shop manager, you can do a decision to properly stock your products based on when those products are required. And that should be informed with data analysis. Um, so just a minute. Now, advantages of visualization in ARA. So it's basically not in ARA in general. Visualization, they tell you a lot of things. You can understand your data. You can make your decision more efficient. You can, for example, sales, if you want to know where the sales were based in location, if you have a very huge concentration of sales in certain region and less concentration in other regions, you can decide maybe you want to enhance more and expand your market and focus on different locations that you are not making a very good progress there. A disadvantage of visuals, sometimes they could be expensive because you need a lot of resources to create these visuals. And one of the resources that you're using in your laptop is a memory. So every time you create a visual, you're actually using a memory, and that is cost implication as well. So another disadvantage, it could be destructive. Now, a destructive visual is actually a visual that has a lot of noises, and it's not easy for somebody to understand. So if somebody's reading your report and you have a lot of visuals and they don't really tell anything, people could be distracted and drift into focusing to understanding those visuals if they are not self-descriptive. So when you're creating the visuals, take a moment to ask yourself that you probably know what is happening because you know the data and you've seen, but somebody who is an independent person doesn't know what is happening in your data. They also need to understand. Um, so take a moment and reflect and ask yourself, is this visual destructive or not? And later I'll share with you the link that I have in my one of my blog posts in my company. It tells you it talks about the advantages and disadvantages of visual, how to create a good visual, what not to do when you want to create a good visual. So first method that we spoke about, the ggplot. So in the next session, we are going to focus mainly on creating a visual using a ggplot, and we are going to use a few steps. First of all, we will need to install the package for ggplot. And after installing the package, we need to load the library. I think we did this in the last session. If I remember well, we installed the ggplot package and we loaded the library for the gg package. So if you haven't done that, I'll share with you the script for you to run and install the ggplot package. Then, um, the first example that we are going to use is an histogram. It's an oversight here. It's not a scatter plot. We are going to check on how to create a histogram using ggplot. Now, the first line, as you see here on the top right, we have said install packages ggplot. So if you haven't run this command at any point, you need to run this command in your ARA script. And we're going to look on how to create a histogram of sales amount using ggplot. If you remember last time we created a histograms, but we didn't use ggplot. We used the bin method, and we are going to see it actually as well today and reperform that bin method. But this is a ggplot. So you see here what is happening. To start, you need to have a ggplot function. Then you have to specify the dataset, and our dataset is named as sales underscore dataset. Then you need a keyword which is AES. And within AES, this is where you provide parameters in terms of what data you need from the sales dataset. So this is the whole dataset. It has everything, every column. But in AES, we are specifying that we need an x-axis to include sales amount. Then you close the AES. So when you jump out of AES here, you have already specified what part of the portion of the data that you want. We want only the x-axis. Then we are going to concatenate this with a special function which is called GEOM, GEOM underscore histogram. So this is used to create the histogram. For scatterplot, you will have the same underscore scatterplot and other functions. You just need to change the histogram to scatterplot or box plot or any another visual that you want to create. So this is the one that creates an histogram. And we are telling that an histogram, we want the histogram to have a bin width of 50. Now, this is a bit different from what we saw last time. Last time we saw bins, and I'm going to repeat again because I think a lot of people are asking about, we are specifying 15 bins, but we're getting 14. So I'm going to clarify that today again. But here the only difference is we are not specifying the number of bins, we are specifying the width of the bin. So the width of the bin is, if we say width of the bin is 50, it means the first bin is going to have a value from 0 to 50. Then the second bin is going to have a value of 51 to 100. There should be a 50 gap between within one bin. So what we mean here is that when we take one portion here, it's from 0 to 50. 0 to 50, then the other one will be to 100, then this point will be to 150, then this point will be to 200, etc. So that is the bin width. Then the fill is, there's a fill and color. Fill is what you fill your bins with, sky blue. As you see, the color is sky blue. Then the color on the borders will be black. So one of them here is the fill, and the other one is the color of the border. Then you have to add or concatenate again with the labels. And in terms of labels, we need 3 labels. We need the label for the title. So the label of the title, the keyword there is title, distribution of sales amount. Then the label for the x-axis is sales amount, as you can see here. And the label for the y-axis is count. As you can see here, you have your count. So basically, this tells you the distribution of cells in terms of count. And you can see most of the cells that were made were roughly around 1,200 because this is the one that has the highest frequency, just a little bit above 50. Probably that you would have said maybe 52 or 53 cells were worth 1,200. So 52 or 53 cells of the products were worth that amount. Yeah, thanks, Joseph, for your response there on the chat. So if you have any questions, just feel free to let us know. So we are going to actually run this on an R Studio and see what is happening and how to create those. Now, the syntax of ggplot can look a little bit complicated, but you'll just get used to it within time. And the good thing here is that if you create your first, maybe if you write your first code in a ggplot and plot the R visual, next time, let me just go back. If you have this skeleton, next time you want to plot the same histogram for a different data set, you don't need to write the code again. You just need to replace the data set, replace the column, change these parameters if you want to, and change the title, change the x-axis, change the y-axis. So the basic structure of the ggplot for an histogram will always remain the same. You just need to change the data set, change the variables and everything else. That makes life easy. So you wouldn't need to go back again and rewrite the whole code again. So as I mentioned earlier, all ggplots begin with a ggplot command. This actually is the first command that you begin with, and you also need to specify the data frame that you are using. In this case, we are using the cells underscore dataset, and we use AES anytime we want something on the plot to represent a value in a data frame column. So, as I mentioned earlier, anything that you'll have AES inside, that's the column that will be taken from the data set. So because we are using a histogram, I'll go back. Because we are using a histogram, we only need to provide one thing, the x-axis. We don't need to provide the y-axis. And you need to understand why we don't need to provide the y-axis here. It's because a histogram is meant to show a distribution. So a distribution is actually, we want to see how sales amount is distributed. So how do we see that? We want to take each distinct or each individual sales amount, and perform a count on it in a block. That means if this is 0 here, and the first bar is 50, because we have a bin width of 50, so the first bar is 50. So what we have here in between is 0 to 50, 0 to 50. So when you go and read the count here, because this is 10, in the middle it's 15, and in the middle it's probably 17 here. So what we are saying here is, in that sales data set that we have, 17 cells, or 17 products sold, they were sold at a price between 0 and 50. So basically, we don't need the y-axis, because the y-axis is basically counting the cells. So that's why we have only specified the x-axis. But in other cases, in AES, you could specify the y-axis. For example, if you are plotting a scatter chart needs to show correlation or relationship between two numeric variables. So you need to specify a variable that will be on the x-axis, and you need to specify a variable that will be on the y-axis. But in this case, because it's an histogram, we just need to specify one of the variable, which is always the x-axis in that case. But in other cases, you could specify both x and y. So the color of point, different colors depending on the variable values. So if you want to maybe change your colors, we saw earlier, you could change colors for different mapping in a column. So any feature that is not related to columns in the data frame are specified outside AES command. So if you just jump outside AES command, you only need to specify any features that are not related to the data set. As I mentioned earlier, the actual type of plot is specified by G or EM. So it depends. If it's histogram, it will be a geometric histogram, or if it's a scatter plot, it will be GOM underscore scatter plot, etc. So there'll be different GOM commands for scatter plots, box plots, histogram, etc. But for histogram, you use this. For scatter plot, you use GOM. Actually, it's GOM underscore point, not scatter. Yeah. For scatter plot, we use GEOM underscore point. And there's always like libraries online for R where you could go and see if you want really to know which function plots a scatter, which plots a box, etc. These materials are widely available online as well. So it's not something that you need to stress on. As I mentioned earlier, we use the plus symbol to combine commands and make a single plot. So um, in this example here, we have added commands here to add the labels. So the first part was getting the data set, then getting the histogram and the features of the histogram. Then the other one will be the labels, which is LABS, including the title, x-axis, and y-axis. Let me know if that is clear before we move to the second part where we write the actual R code for these plots. That is great. So I presume everybody has the data set that we used last time. That was the sales data set. But in case you don't have that one, in case you don't have that data set, I am going to share it again on the chat here. I'm going to share that data set here again in the chat. So can everybody can you upload that data set in R Studio as the data frame? And the data frame should be labeled sales underscore dataset. I want the data frame to be labeled or named sales underscore datasets. So everybody do that and let me know if you are successful. I'm not gonna do it on screen because I'm hoping everybody should be able to upload a dataset in R and a data frame. Let me know in the chat if you're done. So I'll give everybody like 2 minutes for you to load that data set in R and put it in a variable named as sales underscore dataset. The other thing, if you haven't installed the ggplot package, run these commands, please, to install the ggplot and load the library. That is only if you haven't done that before. If you haven't done that before, please do that. Now, if you see my screen here, one thing, if you have that data set loaded in your environment, you should be able to see that data set. And the first thing that is we discussed earlier, we are gonna plot a histogram. We're going to plot a histogram using ggplot. A histogram using ggplot. And to make it easy, this is the code that I was sharing with you earlier in the in those slides. I'm gonna put it in the chat. Now, one thing that I really want you to understand, because I don't want to only focus on creating visuals for you here, run the code, create visual one after another. I want you to really understand why we do this. So this is the output. This is the output. I want you to tell me, I want you to tell me what questions do you think this visual responds to? Or what insights can you draw? Can you give me a few insights from this visual? You give me just a very quick insight about the visual. Anything that you think you can extract from this visual, because a visual is meant to give you insights. And what is the like kind of insights that you'd have thought here the visual would have given you? So I want you to try first, then I will explain it to you as well. So Antoinette is saying, I get this message, path does not exist. Yeah, I think you're loading the data set. So to do that unset, you probably just go and do it, import it manually and navigate to, because what you have there is it's failing to read the location of the data set. So just go to import data set and navigate to where you saved your data set in your laptop and add it. Yep. It's just failing to obtain the path where you stored the data set. So just go manually and tag the path. I did explain to you earlier how to read how to histogram, which shows the distribution of sales amount. So this is basically one application of distribution. Now, what I want from you is, can you give me comments on what you feel, what story this visual gives you? Any insights that you get from this visual? I think one of them I gave it to you when I was explaining, but you can actually repeat it and add any other comments that you have.
Okay, I'll try.
Yes, Amos.
So on this x-axis on the cell amount, we can see this histogram with the highest value from the sales amount of 1,200 uh,
Yeah, the next
amount.
one.
I don't know the range there,
Yeah, yeah.
which the count was sold more than 50 count
Okay, okay, okay. That is a
on
very
that
good
cell
insight.
amount.
Nice, nice, nice. So yeah, so you wouldn't know the exact range, right? I think this is 1,200 here. So probably here will be 1,250. So that's what I want you to tell me is I don't want you to give me the exact value. The way you are supposed to explain it, Amos, you explained it well. You gave a range, then you say cells between this amount and this amount. Those are the frequent cells. So you sell your product at frequent at least prices. So that is the highest cells. What other thing can you think of? Any other one? Any other person? I want this to be interactive. What other thing can you think of from that? Remember, it's just relating the cells and the frequency. Any other try? So if we spoke about the highest cells, you can also speak on the lowest cells. you can say cells between 0 and 50 are less frequent. Those cells are just like 17 of them. I think this is the lowest bar. When I scan these bars, I think this is the lowest bar here. Now, the thing is here, bin width, the higher, the more the width of the bin you have, the easy it is to read your data, to read your visual. If I change the bin width from 50 to 5 here, would I expect more bins or less bins in this data set? Before I run it, I just want you to tell me, would I expect more bins or less bins? Remember, a bin is a single bar. A single bar is a bin. So if I change the bin width to 5, am I getting more bins or less bins? Ismail is saying less. Anyone else? Because 5 is less than 50. Okay. Anyone else? More. Mark says more. Ismail or Mark, any one of you, can you tell us what's the support behind your reason? And Amos, maybe anyone, can you tell us why you feel we'll get more bins here? So there's one thing, there's bins and bin width. This is bin width, it's not number of bins. Actually, you'll get more. I'm gonna run this. So if I run this and I zoom, I'm gonna zoom and create this. Just give me a minute. So you see what we get? We get more bins. Why do we get more bins? We get more bins because we have only specified the bin width to be from 0 to 5. So each bin is 0, 5, 5 to 10, 10 to 15. But this is a mess. This is confusing. You can't read anything here. You can't make any useful conclusion. So that's why I'm telling you. Yeah, Ismail. So I think, Ismail, you interpreted those as the number of bins. They are not the number of bins. That is the bin width. Remember the first method that I taught you last week was the number of bins that I'm going to repeat again, but this is the bin width. But you need to be really careful on this. The less bins you sell, the more bins you select here, the more bin width you select here, the more readable your data is. So if I put a bin width of 100, it's more easy to interpret this because you're getting less, you're getting less, you're getting less bins. So it's much more easier to read this instead of having a bin width which is a bit lower. So that is one thing that you need to understand. Now, remember last time, this is ggplot, histogram using ggplot. Let's draw the same histogram, but this time around, we want to use another method. We want to just use the normal Bayes error method, which is the method that we saw earlier. And this method is just simple. It's just you need to specify you need to use the functional keyword hist for histogram. Then you need to specify the cells data set. Then a bit different. So you need to use a $ and cells amount here to make sure that you get the Y, the histogram x-axis as the cells amount. Then we need to specify the breaks equals to 5. Now, if I run this, I want to show you a little bit difference between. So what you see here, what happens here is we have created the same histogram, like the one that we did here. But right now, we have a different method, completely different. We just specify breaks, we specify the main. This is actually the title. Then we specify the X label, which is cells amount. Then we specify the color as light blue. Then we specify the border as white. Border is the borders of these bars. So here is the thing. There's one thing, there is a thing called breaks. So if you want maybe to change the breaks, maybe if we want to specify exactly, we want 5 bins. So if you want 5 bins, so you can see here we have 3, 4, 5, 6, 7, 8. We have 8 bins here. Maybe if we want to specify a specific number amount of bins, there's another method we can use. Let me share with you first this code here. It's actually the same code as what we did last time. So Sephard is saying, why have we not defined the x and y axis? Are you Sephard, are you referring to the ggplot method or the second method? Let me know first which one you are referring to. But for both of them, you don't need to specify the y-axis because, as I mentioned earlier, for the second one. So for the second one, it's the same reason. We don't need to specify the y-axis because we know the y-axis will be the frequency or the count. So automatically R, if you use hist function, R knows I'm gonna take this value as the x-axis. Then on the y-axis, I'm gonna give you a frequency on how frequently this value appears in the data set. Same applies to the first method. We only specified the x, but we didn't specify the y. So here as well, you only specify the x, you don't specify the y. There's no any difference. The only difference is that there's 2 different methods of writing this. So these 2 codes here do the same thing exactly, but just a different way. One uses ggplot, then the other one uses the hist function from the base R code. That's the only difference there. Now, if let's say if we want bins to maybe we want to create 5 bins, we need to create breakpoints. Now a breakpoint is like so if you see one bar has 2 breakpoints. There's first breakpoint and the second breakpoint. So if you want only a single bar or a single bin, this is a single bar or a single bin, you need 2 breakpoints, the start breakpoint and the end breakpoint. If you want 2 bars, you need 3 breakpoints. You need the first, the second, and the third. So always the number of bins is breakpoint minus 1. Breakpoint minus 1. So for example, here, how many bins do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 bins in this visual. If we have 8 bins, it means we have 9 breakpoints. Because when I count the breakpoints as 1, 2, 3, 4, 5, 6, 7, 8, 9. So every time I know I need to take a breakpoint minus 1 to get the number of bins. So let's say if I have a code here to define the number of breaks, I need to scan my data set using a sequence function SQ. And this sequence function will scan the data set and give me the number of breaks. So we are saying here, we want the breaks we want 5 bins. Let's say this is an example where we want to get 5 bins. Get 5 bins from the histogram. So we want to get 5 bins from the histogram. So we want to map the breaks exactly to using the SEQ function. So now this is actually again optional if you really want to get 5 bins. So you need to use this SEQ function, and in this function you need to specify the minimum cells amount and the maximum cells amount, because sometimes when you're drawing other visuals, you can specify the number of bins. Maybe you want bins to be maybe 6 or 10. That's your wish, but sometimes the ARA can adjust the number of bins for your data to be more sensible. Like an example I gave you last time, having very small cells amount maybe that are not actually visible on your histogram. Sometimes ARA can try to avoid that and automatically ignore the number of bins that you have provided and create its own number of bins. Now, if you want to force it to have actually 5 bins, so for example, here when we specified 5 bins, we said breaks equals to 5 number of bins. We got more than 5 bins because R decided on itself that, oh, maybe 5 is not a good representation. Let me do something that is more sensible, and it got you this graph. But if you want to force it now, you need to use an SEQ function. Provide the minimum sales amount, the maximum sales amount. Then you need to provide the breakpoints. As I mentioned earlier, if you want 5 bins, the breakpoints will be 6. So breakpoint equals to bin plus 1. Bin equals to breakpoint minus 1. As simple as that. Now, when you repeat the same function, like we could literally copy and repeat this, in the bottom, but right now, instead of using constant number of breaks as 5, I'm specifying breaks equals to breaks. Breaks is the keyword. Breaks equals to breaks. This breaks takes the breaks from the break above. So I need to run first this to get the breaks. I need to run that and get the breaks. Then I need to run the second one and get the histogram. So when you do this, you see what happens. You've gotten an histogram that has exactly 5 5 bins. So as you can see on the right hand side, there's the first bin, second bin, third, fourth, fifth. And this 5 bin histogram has 6 breakpoints. The first breakpoint, second, third, fourth, fifth, and sixth. Let me know in the chat if that is clear. And I'm gonna share this with you in the chat here. That is clear, great. So another example here, maybe if I want to define the number of bins equals to 5, I just need to make it more dynamic. I just need to make it more dynamic here. So there's a tendency of R trying to force and give you the number of bins that it thinks is appropriate. Maybe if I define the number of bins equals to 5, I want really my bins to be 5. Maybe let me change an example and use another example. Let's say 10. So I'm gonna run this first part and assign number of bins to 10. So number of bins is 10 there. And I'm gonna generate, now these comments here, I'm gonna generate 11 breakpoints because if I need 10 bins, I need 11 breakpoints for 10 bins. So the same function that we used earlier, SEQ from equals to minimum, na.rm equals to true. So we say this is actually used to ignore null values. So it's going to check the minimum, ignoring null values. It's going to check a maximum, ignoring null value. Although even if you don't ignore the null value, the maximum won't be affected because it's maximum anyway. The null is a minimum value. So if it's a minimum, the only function that is affected is the minimum function. Then you need the length out as we specified earlier. So remember here we only had min and max, but here we have fro and to. So it's basically the same. You could opt to ignore the fro and to and just write it in terms of min comma max. It knows this is from and this is to. But you'll need the length out. As I mentioned earlier, the length out is the number of breaks, which is the number of bins plus 1. Always we have more one break than a bin. And actually assign the same breaks to breaks here when you're creating a histogram. So if you run this, what you're expecting is exactly the histogram, but you have 10 bins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this you should reach the same conclusion with somebody who is using 12 bins 10 beans, 5 beans. You all will reach to the same conclusion, but a little bit difference in terms of how you describe those conclusions. So all cases are still valid in that case. Let me know in the chat if that is clear, and I can put this in the chat to help you if you're taking a long time to either type that or something. Great. Anyone else? Let me know if that is clear. Now, still on histograms. So let's see one more example of histogram. Let's say if you want to assess customer satisfaction. So if I go to my sales dataset here, so you can see the way the dataset it has product ID, product name. So the ID of the product is 101 for a tablet. You can actually see it's 101 for a tablet. Here, there's a tablet for 104, etc. There's city, sales amount, quantity sold, date when you made the sales, channel where you made the sales, either online or in store. There's an option here to see if the discount was made on the sale or not. There's a region where the sales was made. Then there's a customer age group. This is a very good application when you are, so rather than having a customer with an exact age here, you can convert their age into an age group. And it's more sensible because age groups are categories. If you have 1,000 customers, this data set has 1,000 customers. So we are expecting 1,000 different ages. Not necessarily, you could have two customers with 50 years, all of them, but we are expecting 50 different ages, 1,000 different ages. To make those more or less, you use age groups. And if you use an age group, like here, 18 to 24, 45 to 54, we know the oldest customer might just be maybe under 100. And if you have groups of from 18 to 24 here, we have 6 of them. So we're expecting 100 divided by 6, which is roughly less than 20 groups, easily manageable, rather than having 1,000 ages. And you could do categorical, you could make it as a categorical value. And actually, we have another group here, which is 55 plus. So anyone who is older than 55 plus, they've just been placed in a single age group, which makes life more easy. Then we have the customer agenda. We have the method where how did they pay for those transactions? Either they used PayPal, debit card, credit card, cash, etc. Then we have a score rating here. That is the customer is rating the store. So the store is rated 1.4, 3.4, 4.8. So this is the rating of the general of the store. Then we have something else, which is a customer satisfaction here, which I believe it ranges from 1 to 10. Yeah, you can see the maximum is 10, then the minimum is 1. So if the customer is highly satisfied with your services, they would rate you 10. If they rate you 5, they are fairly satisfied. If they rate you 4, probably not good. 1, bad. Probably 0 should have been there as well. They are not completely satisfied. Now, if we want to assess how we are doing in terms of customer satisfaction, we need to see the distribution of customer satisfaction. So I need on the x-axis, I need to have the distribution of customer satisfaction. Then on the y-axis, I need to have the count. Can you, if you really understood what we did earlier, can you use a ggplot function to plot a customer satisfaction histogram? So I want on the x-axis to have the customer satisfaction 1 to 10. Then I want to know how many customers were completely satisfied. It means they had a customer satisfaction of 10. How many such customers were fairly satisfied, having a rate of 5? How many customers were completely unsatisfied by having a rate of 1? So I want you to do that from 1 to 10 and share with me the script on the chat here. just giving you that challenge to see, and you can leverage what we have in the previous code that I shared with you. So I want you to use ggplot to plot the histogram for customer satisfaction, and let me know in the chat. Good way for learning. So then the first one, I want you to use only the ggplot here. So if you're done, just share with us the script that you used and the output as well. Just take a screenshot of the histogram that you got and share with us. And the most important thing, I want you to draw a conclusion and tell me what conclusion you get from that histogram as well. Is everyone on board? Has everyone completed that? Let me know in the chat. I don't want just to send you codes every time. Let me know in the chat if that is clear and you have a result. Customer satisfaction. So I want you to tell me what is the popular customer satisfaction rating. Popular in terms of which one has the highest frequency. And I want you to tell me how many customers were fairly satisfied, were mostly satisfied, and how many were completely not satisfied. So those three questions. The most popular satisfaction rating, how many have the highest, how many have the lowest? Anyone who has completed, it's a bit silent. Let me know if anyone has completed or if there's any challenges in completing that. Okay, great. So I think most of you are still working through that. So I'm gonna give you 2 more minutes. You can leverage what we did earlier. Just you need to update accordingly. Great. Shabani says, I tried, but it failed. I'm just trying to see on what Shabani did there. Yeah, I think, do you know what is the reason for that, Shaban? What did the console say in terms of error? Are you using a variable that does not exist, maybe, or something? So, because if I scan it quickly, customer.
No, it brought me a large bar. It's just like there is no bin anymore, but it's got just like a mat, something like that.
Can you share the screenshot? I think probably
Sure.
your bandwidth is 50 there. You know the reason why, Shabani. Before you even share with me that, I think bandwidth 50 is also tricky there. You know, if you now this is the importance that's why I want you to try because you learn a lot. Between your code, Shabani, and the next one is Aniset. Aniset set the bandwidth to 1, but you had the bandwidth to 50. Why did you have that 50 there? Um, Customer satisfaction rating is 1 to 10. Customer satisfaction rating is 1 to 10. So the highest you can have is 10. Then you are saying the bandwidth is 50. So you just have one huge bar. Everything is within that one huge bar and you won't get anything. That's why you are getting that Shaban. But if you change that to 1, surely you should get something as Aniset got there. Does that make sense? So I used area 50 because I was looking on the sales amount, and the highest sales amount is 1,400 USD. So I can fairly have been with of 50, 0 to 50, 50 to 100, etc. But we're expecting customer satisfaction rating to be 1 to 10. So there's a rating of 1. They're all integers. There is a rating of 2, 3, 4, etc. So you cannot have a binwidth of 50 there. Your binwidth should be 1, only 1. 1. Each bar should represent 1, and we need 10 of those bars. So what Anisette had there is completely correct, and that is the way it should be. That is the way it should. That is the way it should be done. I'm gonna.
Yes, it's okay now.
It's okay. So you
Yeah.
fixed now. Nice.
Yes, of course.
Yep. Anyone else who was able to do that? Simply, customer satisfaction, ggplot cells dataset, specify in AES, specify customer satisfaction as your column, then specify the bin width as 1. Bin width as 1, as I mentioned earlier. The fill, I decided to be orange, and it did blue and black, which is okay. Labels, distribution of customer satisfaction, which is the case. X-axis should be satisfaction score or customer satisfaction. Either way is fine. Y should be count or frequency. As simple as that. When I run this, I'm gonna get a plot here on the right-hand side, an orange one because I specified orange. I'm just trying to change colors here, but you can use any color that you think is good for you. And to respond to those 3 questions, what is the, like how many customers were most satisfied? So there's a satisfaction of 10 here. There's 90, then there's 120. So we have a gap between 90 and 120. This is a gap of how much? It's a gap of 30. So in between it's 15. So this 90 plus 15, it's 105. So you can say 105 customers out of 1,000 customers, 105 of them were completely satisfied because they had a rating of 10. There's customers who are not satisfied. There's a lot as well. It's actually more than those who were fully satisfied, you know. Most of the rating would have been in the second bar, which is a rating of 2, because the second bar has a rating of 2. So most of them would have been here 2. And if you approximate this, maybe it'd be 117, 18 or something like that. You're not meant to give the exact figure, but roughly you know what value it represents there. Let me know in the chat if that is absolutely clear.
Sorry, can you repeat the explanation, please?
Okay. So here we are looking on the ratings. So you said our rating is from 1 to 10, right? We said our rating is from 1 to 10. So we are expecting 10 bars, each bar to represent the rating. So the rating of 10 here, as you can see, where 10 is marked here, the rating of 10, we have, I think it's on this line. On this line is about 115. How did I know 115? Because I know this is 90 and this is 120. The difference between 90 and 120 is 30, and this is halfway. So if it's halfway, the first part is 15 and the second part is 15. So 90 plus 15 is 105. So that's why I'm telling you 105 customers, 105 customers, 105 customers out of 1,000 customers were fully satisfied because they gave a rating of 10 in customer satisfaction. The other question is, I'm telling you 105 customers out of 1,000. How did I know we have 1,000 customers? You can basically do the count, or you can do the frequency distribution and know that you have 110 customers. You have 1,000 customers in that case. So basically, if I you remember last time we had like a tabular representation of how many entries we have in that table, and we saw the entries were 1,000 of them. So that is how I knew that we have 1,000 customers in the data set. So it's basically going through each bar and read the count of frequency. That's what I was doing. So how did we determine 10 bars in the code? So we did not determine in the code, but as I said, R intelligently itself, if you specify a bin width of 1 and it goes through the data set, it checks the minimum and maximum. It checks the minimum is 1, the maximum is 10. So it will go 1, then increment by 1 to the maximum of 10. That's where you have 10 bars in that case. So Ismail, did that? I hope that code worked for you as well, because I can see it's all right. There's no any error in that. Yep. So
So, Brighton, for what I've seen that it's better not to specify the number of beans, and let the error itself to prepare for you so that you can avoid some errors like what I had before, isn't
yeah,
it?
it is the case, but mind you, if you're using ggplot, never specify the number of, there's no option to specify number of beans in ggplot.
Okay.
In ggplot, you specify bean width, but the other method here, the other one that I had here above, where we specify breaks, this is the way we specify number of beans. So if you want to go with that option, choose this. But most of the times I would have used the ggplot because automatically, if you give it a sensible bean width, it creates for you the number of beans. Yeah. So that the choice is you as you, but yeah, I will go for ggplot. So Ismail says in my syntax, when I put space between customer and satisfaction, um, it gives me error. But if I put dot, it works. Ah, okay. So Ismail, you have customer dot satisfaction. Um, I'm not sure what is happening there. Like a dot works, then the because that dot would have been represented in the column name, unless you tell me that you changed the column name or the version of ARA that you're using. Really not sure what an issue is there. But again, it's good that you figured out that. I don't know why it works that way on your side. It's something that you needs to be to do more research. But my first thought is if you change the original data set and add a dot, go to the source data set, go to your sales data set here and see is the column name is there a dot between customer and certification or there is a gap. If there's no and it doesn't work, that will be a little bit odd and something that needs to be investigated more. Okay, I'm gonna go to the next part. We want to see the tabular distribution. So I'm gonna clear first this console by clicking Control R and clear anything from the console. So we want to see the frequency table for categorical variables. And one of them that I want to see is the product category. So if I go back to my sales dataset, I want to see, we have different product categories. So if I scroll, we have tablet, smartphone, headphones, etc. Tablet is in the category electronics, but there's another one which is in accessories, there's home appliance. Yeah, there's different product categories. So if I want to know within different products, how many products are electronics, how many products are accessories, etc. So I need two things. I need first to get a distinct list of product categories. Distinct means unique. I scan the data set. If I find electronic, I take note of electronic. If I find it for the second time, I ignore it. Then if I get the distinct list, I do the count on the distinct list. And the count on the distinct list, if you sum, it should reconcile with the total number of transactions or sales you have in this data set. So it's a simple code there if you want to know a tabular representation. And we saw this earlier. We know there's a function in ARA which is called table. So if I use this function table, so if I say table, sales data set, then product category, it will table the product category and perform a count on each product category. So if I run this portion of the code, it creates another variable which is called table product. And the table product will contain different products in the account. So if I run the second part, I'm going to get count of each product. So you see, there's three distinct or unique product categories. We have accessories, electronics, and home appliance. We have 315 accessories, 375 electronics, 310 home appliance. Now, if you add all these, you're going to get 1,000, which means we have 1,000 entries in that data set. And this is the distribution of accessories for each product in that data set. Mind you, sometimes you can have null values and they should be represented, like it will tell you how many of the null values, how many of product categories are not populated in terms of being null. So this part of code tells you, and I will just share with you the code to make your life easy. You can have that and run, and you'll be able to see the different categories there. Now, I want to leverage that. I want to leverage that category that I've created here, the variable, to find different things. The first thing I want to know the proportional. So if this is 315, this is 375, this 310. If I add this, it's 1,000. If I want to know how much, in terms of count, how much is the percentage of accessories, it should be 31.5%, and this should be 37.5%, and this should be 31%. It's because the total is 1,000. So if you divide by 1,000 and multiply by 100, or we can actually choose to end up in decimal place notation. This will be 0.315, 0.37, 0.31. And if you add all of those, you get a full number, which is a 1. So, so if I want to know the proportional or relative, if I want to know the proportional or the relative, what I'm going to do is just use a prop function. So there's a function called prop. So if I say prop dot table, prop dot table, then the name of the variable that we created earlier, this will give you proportional. So if I run this, I'm going to get same results, but the only thing it's giving me proportional in terms of percentage. So this is 31.5%, 37.5%, 31%. If you add all these, you're going to get 1, which is equivalent to 100%. That's how you know your data is actually complete as well. Because sometimes when you're finding proportional of how many things are accessories, how many electronics, how many are home, then you don't get a result which nets to 100 or 1, you know definitely something is wrong there. So every time when you do an analysis, you should make sure that you sense check your analysis in terms of sorry, I think just a minute. I lost control of my screen. Just bear with me for a second. I think I'm back now. Yeah. So every time when you do your analysis, you need to confirm or to sense check those proportionalities. Now, next thing here we're gonna do is plot a bar plot. Now we are not going to use ggplot. I'm just going to use a normal base function, which is a bar plot, to plot a bar plot for the product categories. And I'm going to explain this to you. So what I have here is a bar plot. So at the beginning, as I had hist here at the beginning to show that it's a histogram. Here it's a bar plot, and we need to specify the data. Our data is TBL prod, which contains the list of products and their counts or frequency. Then, as usual, main is just the title, counts by product category. Then X label is the label of the X-axis because you are plotting a bar plot. Then Y label is the count. Then there's LAS. This LAS is it specifies whether the labels should be vertical or horizontal or parallel. So it can take different values. If you put a value of 0, it means you're making a label parallel. Those X labels, you are making them parallel. But if you put a value of 1, you're making them horizontal, 2 perpendicular, 3, you're making them always vertical. Actually, what I'll do is I'll send you descriptions of like these functions. I'll send you the description in the Google chat later of like I'll take snapshots of this code and put a little bit of description to tell you what each part does. But this actually tells the orientation of the X-axis labels. So if I run this, I'm going to get a bar plot and bar plot for accessories, electronics, and home appliance. And you see, actually, electronics is the one that is more famous in terms of category because it has a lot of cells compared to accessories and home appliance. Now, the 0 that I had here, if I change it to 1, I'm going to make those labels, accessories, electronics, as vertical. You see them, they're horizontal right now. But if I change that to a 1 and run this again, and why did that not update? Oh, 1 is horizontal. Oh, yeah, 1 is horizontal, sorry. If I want them to be perpendicular, I think this needs to be a 2. It's a 2. Quite tricky to remember all these. Yeah, if I do a 2, you see they go to vertical. If I do a 3, it means always vertical as well. But that is not, it's not more intuitive. It's not readable. So I'll just default back to 0, which is always, which is parallel, which is horizontal as well. Yeah. So you see the difference in LAS and let me try to comment out LAS. I think it's not mandatory. If I do it, what will be the default? So you see, if I remove LAS, it still works and it still gives me horizontal. So I think the horizontal there would have been the default one. Now try different things. I don't know if color is mandatory. Let me remove color and remove the last comma and see if it is mandatory. So you see, I've removed color and the graph still works and the default color is gray there. So what I really want you to understand is that it's not like everything that we supply in this function is mandatory. Actually, the data set is mandatory here because if you don't have it, you don't have the graph. But the rest of the things is just your optional and these aesthetic things trying to make the visual look more good, like using a color salmon. I would have thought color salmon is a fish, but in this case, it seems to be a color, but that's fine. Let me know in the chat if that is clear and if you really understand how we do these things. So it's not like everything will be like mandatory. You just need to know which thing is mandatory and which one is not mandatory. Next thing, I want to challenge you now. And okay, let me show you. This is a bar plot using arrow function. I want to use ggplot. I want to use ggplot to plot the bar plot. So what I want you to use ggplot to, let me actually put for you the question here. Use ggplot. This is what I want you to do. Bar chart for customer gender, categorical distribution. I want to know the categorical distribution of gender. One thing here is I want to know the same distribution. You see the product category, but I just want to see the genders. Instead of product category, I want to know what gender actually engages mostly with our platform in terms of making sales or buying products. Am I getting more sales from male or female? Actually, in the data set here, that we have also others. I know you know the global issues about everything about gender, something that I don't want to discuss, but in the data set, there's another category of gender that is called others. I don't know what is it, but it's just other. So we'll just leave it as an other. So I want to see how many.
I'm sorry, Brethren.
Yeah.
I just have copied the code and pasting to my script, but it showed me an error. Maybe if I can share with you, you can assist.
Yep. Share with me that. Meanwhile, while you share, I want people to create a histogram for customer gender using ggplot. And to make your life easy, the function that you'll use in ggplot to plot that will be GOM_bar. So just work on that and give me the results. And Shabania, you can share with me what is troubling you.
This one here, if you can see it.
Are you sharing your screen or something?
Yes, the screen.
I'm not sure if you can share your screen while I'm still sharing mine.
Okay.
Oh yeah, now I can see. Actually, that's interesting. It's like Slack nowadays.
Yeah.
Okay.
Yeah.
So
Any
first
mailman.
Shaban, do you know where the error is
Yeah.
coming from?
Okay, samahani. Samahani basi dakika moja. Yes.
I,
Yes. I see this one. If you can see at my script there.
yeah, you know where the error is coming from?
I don't know.
Why? Really? You should know. You know why?
Uh-huh.
If you look at your screen, anything
Yes.
that is red is danger, right?
Okay.
Where do you see red? You see line 123. There's an X there. So you exactly know what's the reason there. I can see, I know the error, like, but I want you to think a little bit there. Or anyone in the chat who is in the class to tell us what is the issue there. Mm. I think I actually,
I
that's the
think
code that I shared with you, and I I did an error. I think, of course, it was accidental, but I know what is the error there. What is the error, Amos?
the comma after the end of the count, you need to put a comma.
Perfect. You see, everything there, mean, X lab, Y lab should have a comma. I removed the comma because I had a comment earlier, then I mistakenly pasted to you this, but I think it's a good thing I did that accidental because it makes you learn as well. So run that part of code again. And make sure you to save your code when you're done, guys, because if you don't save it, you're gonna lose this code here. So make sure you save it. Um, so Jasmine got it right as well. Put a comma. Yeah, spot on. Was anyone able to create a ggplot? I'm gonna give you 2 minutes. So take it as a break, and I'm going to be away from the keyboard, but let me know in the chat if you get it. Just 2 minutes away from keyboard. Any luck? Any luck on that? Let me know in the chat. Was everyone able to use a ggplot to plot a bar representation of customer agenda? Because it's so Mark, can you give me the full code? Can you give me the full code that you used? Everything, like including labels and everything, color, if you had, or let me actually just try what Max applied here. Probably, but it wouldn't have labels. So this is what Max shared. So it worked well. It worked well. Okay. So this tells us from Mark, I can see customer gender, I can see count, I can see female, male, and other. So we have more cells to female, followed by male, followed by others. So you didn't specify the X label, Y label, and the title, but the X label, intelligent R, knew about that. And the Y label is just a count because R is doing a count and the ggplot bar, but we don't have a title. That's the thing, you know. I'd have encouraged you to have the title as well. You haven't specified the color, so it's like dark gray here, but you can specify any color that you want. So this is one of the approach that you can use there. But if you want maybe to be more detailed, maybe if you don't want, if you don't want, maybe you want to specify excess gender and not customer gender at the beginning, and Y as count or frequency. Title you want to specify as customer gender distribution. Then you use GeoM bar, as I told you earlier. Fill equals to orange, that gives you a color for the fill. Sales data set, that is the data set. AES, we said anything that we need to plot goes through AES. We need to plot a customer agenda. So if you use GeoM bar, it means it goes through the customer agenda in text and gives you the count for everything. So if you do this, slightly different, but the same results. The only difference is that we have a title here, we have a count, we have gender here, and then we have the categories for that gender, male, female, or others. Let me know in the chat if that is clear. If that is clear, we can move to another thing, which is a can move to another thing, which is a pie chart. Which is a pie chart. So pie chart. Pie chart is one of the examples that is used to show distributions. And let me clear my console. And most of the times, if you want to show, maybe if I want to know the distribution of product category share, is what I did earlier. I could have used bar plot, but I can also use a pie chart. Pie chart is also a very good example for that. So nothing changes here. Again, it's just a different type of visual that is suitable for the distribution. I'm gonna share with you the code and explain to you what is happening here. Again, a little bit complicated right now, but I want to explain to you everything that happens here. So remember, we are using pi. It's a base arrow function to create a pie chart, as simple as that. Then within the function, you provide the input data. The input data is product category table, which has the product categories and the count for each product category. So this is a vector, which is in a table format. It contains the names that represents each category, as we saw earlier, and it contains the values that represent the size or frequency of each category in terms of count. Then we have the main function here, which is basically a title, main title of the pie chart. Then we have the labels. Remember, labels. It's just we want to label our pie chart. Without labels, you can't understand what is going on the pie chart, what portion represents what. So labels, we use pest. So pest is actually pest with a 0, meaning that we want to concatenate or join. We are concatenating the name from the table prod. So table prod contains names of categories and the values, but we want the first thing to be concatenated is the name. So take name like electronic, then move to the next line and give me the value. So if you use TBL underscore prod as its own, it gets you a value. But if you use name function in front of that, you get the name of the category. So essentially here we'll have on top a name of the category, then on the bottom we'll have the value or count of that category. Then the last one is just it's just the color rainbow length of, which is a little bit like telling that we want you to assign the colors of the rainbow. The colors of rainbow, we know it's red, green. There's like a lot of rainbow colors. There's 7 of them in the rainbow. So depending on the number of categories, it would have gone there and picked if you have 3 categories, it will go there and pick three colors from the rainbow palette. I'm not so sure about the order of which gets picked and which comes next, but what we know here, it takes the rainbow colors, and what it does here, it calculates the length of that to know how many colors to bring. So if you say rainbow bracket 3, it gives you 3 colors of rainbow. If you say rainbow bracket 4, it gives you 4 colors of the rainbow. 5 gives you 5. So it goes through the length of TBL prod, which is three categories, and gives you 3 rainbow colors back. So if you run this, you see what you get here on the right-hand side? Product category share. It tells you electronics, we have 375 of them. Home appliance, we have 310. Accessories, we have 315. So this is the distribution of product category share. And electronics and 375, this is done by the pest function. We have the name here and we have the product. So if I accidentally, let's say if I accidentally remove this and run this, trust me, can you understand anything from what we have here on the right-hand side? You can't understand. That is a pie chart, but it's useless. It is useless because I just see green, I see blue, I see red, I see the numbers, but I don't know what number means what. I completely don't know that unless I introduce back this part. And I can tell you it's better you leave the second part where you show the numbers. It's better if you leave this, although it's not ideal. It's better when you leave this. Because at least I can see, okay, this is electronic, this is accessory, this is home appliance. And pie chart is a little bit tricky. Pie chart can deceive you. Sometimes pie chart can deceive you. You might think electronics is larger than accessories if the pie chart is a little bit flipped. So that's why it's very important for us to have the exact numbers here. So if you run this, you get the exact numbers as well there. And I'll show you one example where Apple used a pie chart to deceive the crowd about the. Actually, you couldn't say as a deceiving. They used it in a clever way to to portray their market share. Let me just look on that example right now because we are talking about pie chart. So I'm gonna search for the market share uh, pie chart deceiving. So sometimes when you don't use well the pie chart, it can deceive you. Um, Yep, there is this popular photo for. There is this popular photo of the Apple CEO, Steve Jobs. I'll bring this into. This is a very good example of an Apple chart. So there was a time that Steve Jobs was trying to present market share of Apple. So initially, still they didn't put these percentages here. They didn't put these percentages here. They only had colors on the pie chart. And what they did, they flipped the pie chart. So if you see the green one here is an apple. You see green one is actually, if you just look quickly, you can think that the green one is actually bigger than the purple one, which is others. But that's not the case. If you put the actual percentage, you see green is only 19%. It is actually way less than 21% here. But if you look on that quickly, um, you might have been deceived. So if you read on this story, it tells you on June 2008, Steve Jobs took the stage in San Francisco to unveil the new iPhone. As he presented the new market share of Apple following launch of his first iPhone, he illustrated it with this graphic, which is a little bit tricky. So there's a question here. Doesn't the green slice here look bigger than the purple slice where the but the percentage indicate otherwise? So very tricky sometimes when you present data in a pie chart. You can do it on purpose to, it's not like, actually you have not, it's not like you have lied to people. It's just you have twisted the pie chart and you make people think that you have a bigger market share um, more than the purple one, which is a little bit not the case. I'm gonna share with you this link. So when you get time, read these stories and you learn something about the use of pie chart. And this is like very, very important. I think it's one of the examples that I gave. I recently worked with one of the companies in the UK in the project. I was developing for them a solution for visualization and data storytelling. Then I gave this example in what I was doing. So cautiously telling them that pie charts are good to use, but most of the times people would avoid them. You need to use them if you have few categories and when you need them for distribution. You cannot use a pie chart if you have 50 categories to present data in a pie chart. Imagine that you have 50 categories here. That what you'll be getting is actually a noise there. And actually, let me show you one example from my company. I do a lot of data storytelling, and I'll show you one of the bad examples to use a pie chart. One of the bad examples to use a pie chart. If I go to data storytelling here, actually, this is one of the examples that I'll give you later, but I want to zoom into this particular. I'm speaking about the do's and don'ts on the visualization. So you see here, this is a good visual here. It's a good visual, simple and has color unit correct. So like you see, total is 20, 17, and 3, actually correct. This is actually bad because there's a lot of things going on, and this is ugly. if you're drawing a pie chart like this and presenting your data, you need to question yourself. So I don't want anyone from this boot camp, when you go to your workplace or when you work with a client and you share with them this, you're gonna make your clients panic. They are gonna hate data. We don't want people to hate data. We want people to like more data. So like visuals like these, like very quick, simple, and easy. So more about data storytelling, just go through my website and you'll see more details here on what you're supposed to do and what you're not supposed to do when it comes to data storytelling. Yep. Let's get back now on more coding. So I want us to plot. We have done a pie chart. We have done a bar chart. Let me do the pie chart for gender. Let me do a pie chart for gender. Actually, I can give you that as an example. So, can you, because this is meant to be an interactive part, develop a pie chart to show distribution of gender. Remember, when you get the distribution of gender, when you add everything in that list, it should get you back to 1,000 because you have 1,000, a data set that has 1,000 entries. And I made sure that in that data set, every field is populated. There's no empty or null values. So develop a pie chart to show gender distribution. I want you to use the pie function. Do not use ggplot. I want you to use the pie function. I'm gonna give you two or 3 minutes for you to do this and share with me your code when you're done. I'm just gonna save this. So remember, if you still want to maintain this code, you need to save them. You need to save them for you to maintain them. So do a pie chart for gender. If you're struggling in anyhow, let me know in the chat because we're here to help you. And sometimes what I want you to hear is just the distribution in terms of count. Sometimes you might go into small details and say, how many cells did I produce for electronics? How many cells did I produce for accessories? How many cells did I produce for home appliance? And instead of having a count, you have the cells amount. So these are the kind of questions that I want you to ask yourself and find a way to plot them. So when you are done with the session, that data set that I shared with you has a lot of things for you to learn. You can ask, if I ask you how many sales were made, what is the amount of sales that was made to female customers who bought products online? So two things, should be a female and they have to buy a product online. What is the total value of sales there? If I ask you that kind of question, I'm expecting you to be able to respond to that question by writing a R script and generate a visual to respond to that. And we are going to cover that kind of visual in the a few minutes to come here. We want to know maybe two things. We are combining two things, actually three. We want sales, we want the gender, and we want the store. So we want sales for female, which were made in store. Sales for male, which were made in store. Sales for men, were made in online. So we are cutting across through different three things, because most of the visuals that we have looked at so far were only two-dimensional. In fact, one-dimensional, because the dimension is the product, then the other one is just a count, which is not really a dimensional. It's just a statistics in the data. But we want to include more dimension. We want to get the product, we want to get the gender, we want to get the sales, or we want to get the location, gender, and sales. And we're going to see that in just a few minutes to come. Time is not our best ally, so let me know in the chat if you are able to create that pie chart. But first thing that you need to do, you need to initialize the data set for gender, or using a table. So use the gender is what we use for products categories. Same applies. You need to do for gender. Anyone who has made any progress, let me know in the chat. If not, for the sake of time, I'll just put it here. Basically, still the same thing as what we did earlier. Nothing has changed. The only thing that needs to change is initiate a new variable, gender TBL, then table it to get the statistics, and use the customer gender on the sales data set. So if you run this, Stephen has something there. We're going to go through that, which is great. So if I run this gender TBL, if I just want to print what is gender TBL, I can just select this and run it. I'm going to get female, male, and other. You see, we have 359 female, 327 male, and 314 others. Then in the pie chart, I'm going to have a pie. Then I'm going to have the gender TBL as the data set. Did I create gender TBL earlier? I think, Steve, you haven't shared how you created the gender TBL. So I'm not sure if I created the gender TBL earlier, to be honest. I didn't, but share with us. Because I believe, Steve, if you just run gender TBL and you have not created it, you're going to get an error because it doesn't exist in R. So the main is just customer distribution, the label you paste, you combine name and value, as we mentioned earlier.
Right on. I see the gender TBL in your environment, so I don't know.
I've created here. You see this first line here?
Okay.
Yeah. Yep. So Stephen has shared how he created the gender TBL mapped to table sales data set. Perfect. That is absolutely correct. So when you run this, just wait for it to update. So you see, actually, we have a pie chart here, male, female, and other, and the labels. So yeah, Stephen, what you did is absolutely correct, 100% correct, and well done on that. Well done on that. But remember, you need to run the gender TBL first to create it, then use the gender TBL on the pie chart there. We still have half an hour to go, and we are going to finish on time. So let me know if you want me to slow down or proceed with the same speed. Next thing, box plot for sales amount by region. So we want to plot a box plot for sales amount by region. This is what we want to do. Now we are introducing a dimension, 2-dimension. I want to look on the sales amount, then the region. Sales amount, then region. We'll just give you a few minutes if anyone is still looking on the previous code. Just give you a few minutes for you to wrap up. So box plot, the next one. Simple as I think last time we saw a box plot, but it was more of a one-dimensional box plot. The box plot that we saw earlier, so box plot that we saw earlier was just sales amount on its own, but now we want to relate sales amount with a region. I'm gonna start this. I'm gonna make it very simple to begin with and show you the difference. So the last time what we did is just give me a minute to get what we did last week. We made a very simple box plot of the sales amount. So we made a very simple box plot of the sales amount, which I also want you to make that right now. So it's basically, I'm not into region yet. I'm just on the sales amount. It's basically box plot, then sales data set. This is how we define we need sales amount. And this is the title, which is okay. Then this is the label for the y-axis, and this is the color. So if you run this, you're going to get a box plot. And as I showed you earlier, the box plot would be like this. It shows you the distribution of the sales amount. But this sales amount here is for all the regions. We don't have anywhere a filter here to filter a region, store location, or etc. But if you want to break down this into regions, we want to have if we have 4 regions, we want to have 4 box plot, each for each region. And if you remember earlier, the way I described how to read the box plot, I told you the line in the middle represents the median, which is the second quartile, which is 50% of the data. Then the bottom line is the first quartile, represents 25% of the data. Then the third line here is the third quartile, which represent 75% of the data. Then the top line is the maximum, then the bottom one is the minimum. And normally when you plot box plot, you in some cases you might have little dots on top. These are normally termed as outliers. An outlier is something that is outside of the range. Let's say if you have a population and everybody's age is ranging between between 10 to 60, then all of a sudden you have 2 people. One of them is 120, the other one is 130 years old. Those will be termed as outliers. And in a box plot, they'll be represented on top as in dotted notation. Now, we want now to add a single, variable there. So we want to add a sales by region. So if you want to add that, what we will do here, let me just share with you this first so that you can plot the normal sales box plot. So this gets you a sales box plot. Then I'm gonna edit that by adding a region. So if you want to add a region, you need to add something like it's just like an approximate sign, then sales region, sales data set indexed by the region. So it's slightly a little bit different. I think it wouldn't make changes if we have the quotes in front and at the end. So I can change the title instead of sales amount. I will say it's sales amount by region. It's just still sales amount, but I'm breaking it down by region. Then sales amount, I want the color to still be light green. So what I'm expecting here is a breakdown. Same box plot, but give me details for each region. And you can tell from which region you make more cells, from which one you make less cells. So if I run this, the magic appears here. 4 box plots created there, representing each region. It's basically, we took the first box plot for the total cells, then we broken that down into individual regions. So we have east, north, south, west. Clearly, if I ask you there which region is making most cells, you'd have thought that would be east region because the box plot, even if you see the median is way higher, then you see the 75% third quartile is a bit higher compared to others. South and west, actually south makes more cells than west. I can see the median is a bit high. North and south, more or less, they make more or less the same cells. But the first one will be east, followed by south, north, then the last one would be west in that case. I don't like the X label. You see what happened in the X label here? Cells, dataset, region. So if you take this to somebody outside, like somebody who is reading your report, they won't understand what is the $ region cells. We just want region here. What do I need if I want to change this into region? What do I need to change in the code to change this into only region and remove the $ and everything else? Let me know in the chat, what do I need to do? I don't know what to do, but I want you guys to help me. I'm stuck there. Can anyone help me? What do I do? Time is not best ally. Yeah, Mark. Yeah, I think Mark, that is logical. That's very logical, Mark. That is true. That is what we need to do. Add an X label because we didn't have an X label. Then run it. See, magic happened. It changed to region. There you go. You have your region there. So everything is like very, very important. Another thing, cross tabulation. I'm gonna go a little bit fast now. I think we have only 20 minutes. Cross tabulation, 2 categorical variables. If you want to represent 2 categorical variables, you'll use cross tabulation. So for example, if you want to know the sales channel and gender and the count, it means we are creating like a matrix. We want a matrix to have gender, then we have to have sales channel, then we have to have the count. So it's just basically use the same keyword table, then specify the same categorical variable, use a comma, then specify the next categorical variable, then print the cross tabulation variable, which takes account 2 categorical variables. So if I run that, you see I'm getting a breakdown of gender and sales channel. So I can see 175 female bought things in store, 184 bought online. So female prefer slightly a little bit online compared to store, but male, I say male as well, they do prefer online. Okay, anyone loves online. This other gender is the one that does mostly on store compared to online. Yep. So that is how you now you can use this to plot any other visuals that you want to. Customer age group, again, if we want to see the distribution of customer age group, let me share with you this on the chat. Let me share with you that on the chat. Distribution of customer age group using a bar plot. So basically, it's a mix of visualization and distribution. So you see, like some these visuals are the ones that are used to show the distribution. Customer age group now, this is basically just simple. We are using a bar plot. Now, It's a bit different here. I did not have an independent variable to map table into that variable, but instead of having that, you could have directly that definition of table, cells, dataset, age group within. So instead of doing what we are doing here, instead of having this extra line, you can take what is inside here to the dataset. That's what we did here. We took directly the customer age group into where we need to have the data set instead of using a variable. You can also use a variable. The choice is yours. You are not limited here in what you do. So if you do that, you can see age groups and the count in terms of distribution of age groups. Now you can see what age groups is actually more popular. And I think it's just 25 to 35, and the less popular is 45 to 54. It means we don't have a lot of customers who are aged between 45 and 54. So if it's a marketing strategy, maybe you need to focus into this age group and do more work and more campaign and get more customers from that age group on board. Maybe you don't have the products that they want, so you will need to assess that and get into the bottom of the issue. Time series. Again, I'm going to show you how to do a time series. Time series is where you use a line plot. In our data set, we have a column for date. So we know when the sales was made. So we want to see how does the sales behave within time. So first thing, before you do a time series, there's a column for date. We need to format that column into a date format. So we need to ensure date is in the date format. So remember, this is the variable that tells the date. It's called date, which is the column. And that date is within the sales data set. So we are mapping that date from the sales data set as.date. As.date converts date into date format in R. And the input that we are supplying there is nothing. It's just still the same. We are supplying the same date. So take the original date, convert it into date, then assign it into the same column. So that column will be converted into a date column. So most of the times you see what we do in this programming, we take a variable, then we assign to itself, but we do a transformation, which is sDate first. So if you run that, you're going to get that variable converted into a date type, and you can use it now for cells. Now, before you do that, you need to aggregate by date. You know what happens here? It's a funny thing because if I go to my sales data set here, and if I go to a date, let me order them. You see there's a date on New Year. There's multiple cells. There's 1, 2, 3, 4, 5, 6, 7, 8. We have 8 cells on New Year, and we want to plot a time series of those cells. But on our graph, we'll have only a single date on New Year. We won't have like 8 dates for a New Year. So we need to do something which is called aggregation of cells. So you need to aggregate in some cells over the date. So go on the date column, then sum the cells. Simply, what we need to do is this. We need to aggregate the daily cells using a function aggregate. So you just need to specify aggregate. Then you need to specify what you want to aggregate from what data set. We need to aggregate sales amount, and we need to aggregate that over a date. So you need something that you need to aggregate, and how are you aggregating that, or how are you grouping it? We are grouping it by date. So aggregate over a date. Then you need to specify the data by saying data equals to the name of the data set, and you need to specify the operation for the aggregation. So in a single date, take sales amount and add them. You could do a subtraction division, but we want the aggregation to be a sum. So when I run this, I'm actually getting a daily sales. If I do this, I'm getting a daily sales. Like if I only select this and run this, I'm getting a daily sales. You see the output that I'm getting here is a day and the sales that was made to that day, a day and the sales that was made, a day and the sales that was made, a day and the sales up to the last date that we have is on March 22nd, and the sales that was made on that day. So if I go back here, you see what happens here in New Year 2025. Total sales was made was 8,000. If I go back to my data set, I've sorted. I'm gonna sort this from the lowest date to the highest. And I did that twice. I'm gonna do it again. So these are the New Year sales here. These. So if I sum these, 1 plus this plus this plus this plus this up to this point, if I sum all these cells, what I'm telling you is you're going to get 8,265. That's what this function does here. Let me know in the chat if that is clear. Aggregation of cells first. Before you plot them on a time series, you need to aggregate them. Because this is ARA, if you use a BI tool like Power BI, AWS, Tableau, Google, what those BI tools, they would aggregate for you automatically, and you need to specify the aggregation. And later, actually, we're actually planning a bootcamp on BI tools, on where you can see how to use the BI tools like Power BI, Tableau, Amazon QuickSight, etc., and SQL. But because it's ARA, you need to do the aggregation on yourself there. Then when you have the daily aggregated cells, that's when you use them to plot, to do a line series. So if you do a plot, line series is defined by plot. So if you do a plot, you plot what daily cells. And daily cells, we have two things on the daily cells. Remember, we have the date and the cells amount. So we want to take the date as the first variable. Then we have to take the cells amount as the second variable. As the second variable. Then we have type equals to, is this one or L? I have to confirm about this. I don't actually remember what type is, but I'll have to confirm. Then we have the main, which is the title, and we have the X lab there, X lab, which is the X axis, and Y lab there is the Y axis. And color, which is dark red in that case. And when you run this, you're expecting to get a line chart there. You expected to get a line chart there. Let me know if that is clear. Let me just check on the library on the type, but I believe this will be the type LS line chart, because plot gets you everything. It has to decide if it's a line chart or something else there. Just give me a minute here. Let me know in the chat if everything is clear. If you have any questions, please. Yeah, I was right. L stands for a line chart. Yeah, L stands for a line chart. Yeah, yeah. I think plot can give you a scatter or something else when you specify L or other type. Yeah, yeah. Yep, that's true. If I change this L into a P, I'm gonna get points instead of a line. I'm gonna get points. Let me run this and check. Yeah, you see what happened there? I didn't get a line, I got points, only points. It goes through each date and points. But if I say a line chart by L, if I change this into L, it connects those dots into lines. That's the only difference. That's the only difference. So there's like a lot of things you can do there. You can use both. If I want to have a line and a point, like I want to have a point here and a line, I can use a B. If I change that to a B here and run this, I'm gonna get both points and lines, but it doesn't look so pretty nice. But I'm just gonna put an L there for a line. So this tells me you can actually see the trend. It tells you that on March somewhere, this is March 1, probably here is March 7th or something like that. That's the lowest point that you had sales. So you need to see what happened on this date. Did you close some stores? Was there an issue that disrupted your sales? But if you scan again all the dates, you can see the maximum sales is here. It's very odd to see, like on March 6, you had a lot of sales. Then the next day, like March 6, you had your highest sales. Then the next day, you had your lowest sales. There's something odd happening there, maybe. Maybe on that particular date, you are running a marketing campaign and everybody was out there like doing a marketing campaign and you had a lot of people to get them online to buy things and install. Then the next day you gave yourself a holiday or something. Could be the possibility. So if you're discussing with a client or something, you need to get into the bottom of that. Why we left the data set name sales data set? What do you mean there? So Seford says, okay, I understand. We created another variable. Yeah, yeah. So if you understand that, that is pretty
It's
much.
line number 153, the sales data set. Here, when we were plotting, we did that by creating the daily sales, which is another variable.
Yeah.
My question was wondering when we are plotting, I was looking for the
Okay.
data set.
You understand now it's used here.
Yes, yes.
And I like that question so much. That's Seford. Yeah, that's a very logical question. And I like when you guys ask these kind of questions. It means you understand and you're getting to the bottom of the problem. Eh, one last ggplot sales channel. ggplot using ggplot on the sales channel. Maybe perhaps two more last. We can use ggplot geom to plot the sales channel. And this is really interesting because what we are doing here, we are using a ggplot using the sales data set.
You have not shared the codes yet.
For which one? For this one?
Yeah.
For the line chart, right?
Okay, sure.
Okay, let me share with you. Thanks for the reminder. I'm gonna share with you here. Just make sure that you just copy them and save them on your end, because at the moment we end the meeting, nothing will be here. But if you guys, I can actually, I'll also send you the code and the Google class as well. I'll share with you the scripts. Let me share you I'm gonna run this first to make sure if it works well before I share it with you. Something interesting here, sales channel and gender. Two things. Now it's becoming more interesting now. When you use ggplot to have two things. So remember we said anything within AES is the one that will be displayed in terms of data. So I've included X as sales channel. So and the X-axis will have the sales channel, which is either in store or online. Then I want the sales channel to be filled by customer gender. To be filled by customer gender. This is what we say now. The sales channel has three different gender. There is for female, there's for male, then for other. Same applies to online. You see the distribution between female, male, and other. So this tells you if you're looking in store, a lot of people, female, purchase in store. Same as online. Most female purchase online compared to male and the other gender. So you can see in both categories, female does well in terms of store or online. It's just female are very good in purchase. They like buying stuff compared to men, which is quite normal. So you can actually see and the distribution. And when you focus on female, you would have said that more female like to purchase online compared to in-store because the online bar for female is way higher compared to the in-store. Now we have we've said position dodge. If we say position dodge, we mean that we want the position to be side by side and not stacked. Let me copy this and change the position to stack and show you the difference. I'm gonna share this with you in the chat. So if we say Dodge, we want them to be side by side. I prefer the side by side formatting. If I change this into, instead of George, now these keywords are the ones that you just need to get used to them, and you'll get used to them when you read the other libraries and documentation. If I change that to stack, you see what happens? They get stacked on top of each other. It's like a stacked bar. So we have in-store and online, but we have stacked. So the first category is for other, then male, then female. But I don't really like the stacked bar because unless you put for me percentages inside, if you tell me this is X percent, 30, 20, 50, that's when I'll understand more intuitively. But the reason that I don't like the stack, it's sometimes very hard to interpret. But if you have the Dodge, way, you have them side by side there. And one last thing, ggplot for product category and season. Product category and season. Product category and season. So remember, on the right-hand side here is just the count. If you specify only two categorical variable, the y-axis will be the count or frequency. It won't be anything else. So another ggplot, I'm just going to use the bar plot. I'm going to use the position as stack, and I'm going to fill that with season and product category. So the first one is X season. It means that's the one on the X-axis. Fill is just the breakdown. Season will be broken down by product category. So we're expecting season if it's summer, winter, fall, autumn. In summer, we want to see electronics. We want to see home appliance, and we want to see, I don't remember what was the other third category. But because we have 4 seasons, I don't want them to be in a Dodge position, because in a Dodge, I would have created a lot of bars, but I just want to stack them, to have them, few of them, by stacking them on top of each other. So if you stack, you see, you have fall, spring, summer, winter. So if I had chosen Dodge here, if I had have chosen Dodge, it will be okay. There will be a lot of information. There will be a lot of information, you see. But sometimes maybe this is okay. Yeah. But this is okay sometimes. It depends on your ability to interpret it. So another question is, what can you tell from these visuals? That's the other important thing that I want you to know. So you can have that, or you can have position as stack as well if you want to. Let me know if that is clear. Let me know if that is clear. We have 2 minutes and we're going to finish within 2 minutes here. If there's no any other question, I can move to a PowerPoint for closing remarks.
Sorry.
Yes, Jasmine?
Narudisha nyuma sana kidogo.
No worries.
I have understood what you have been explaining about ggplot and stuff, but until now I don't know how to upload a document into the R script.
Wait a minute.
So I was just listening without practicing.
Interesting.
I was writing codes without practicing because I don't remember how to upload the Excel into the R script.
Okay, it's good you told us, but you should have told us at the beginning when I asked, but it's not a problem. I'm going to show you how to do that, okay?
Also, another question.
Mm-hmm.
If you want to practice how to plot the data, you said you have to install the ggplot, right?
Yeah.
But we are also told if you install tidyverse, it also contains the ggplot package. Is that okay? Like instead of
That's
using
okay.
ggplot, you oh, okay.
Yeah, that's okay. Yep. That's okay as well. Yep. So, any other question before I respond to Jasmine? Because to upload the data, Jasmine, it's just simple. Import data set. You see where we have the import data set here on the environment section. You just need to say import from Excel. Then you browse. In my laptop, I'll browse my data set, sales data set here. Then I'll click on open. It will tell me the location where the data set is coming from. And if you are getting it right, you should see the preview of the data here on top. This is the preview of the data, product ID, etc., etc. This is the way you import it if you want to write it directly on your console, but you need to specify the location again. You need to specify the URL. But if you click on import, simply as that, you have your data set imported already in Excel, in R. As simple as that, Jasmine. If you struggle on this, you can stay back for like 5 or 10 minutes and I will show you how to do it. We are nearly the end. So, fun fact or data meme for today. From the link, because we have studied a lot about visualization and I've shared with you a link of do's and don'ts from AI Data Hub, the link that I shared with you earlier. And you can see here, there's somebody who created a nice report in data and this mom is asking, can I get your report? My kid has insomnia and I think it could help. Like the kid has a problem that he can't sleep. So she thinks that report that you presented there with all your data, graphs and everything was really boring. I was able to sleep. I think my kid, if I read to my kid that report and I show him, he'll also be able to sleep. You know, she went back home and she was saying that any relationship had a p-value below 0.005. You know, when you deal with R, the machine learning, we thrive to have p-value less than 0.05 to measure the accuracy of the model, but that is very boring to people. You cannot go and present to people and tell them that this the p-value is, they're not data scientists, they're not data analysts, they don't know what is p-value. You need to make it very simple. You need to make it very, very, very simple. And that's what I also do in AI Data Hub. I make, like I know under the hood, we are doing complicated things, but we make those things very, very simple for everyone to understand and appreciate the work that we're doing. So make sure your visuals are very easy and very well understandable. Les, any question?